Hi, Greg Bruntz here with another useful tip for you. Today we're going to talk about using subcooling and superheat to troubleshoot a heat pump system. These same rules kind of apply to using it to an air conditioning system. On the screen behind me I've got a job checkout sheet that we use in tech service all the time. It gives you a place to be able to lay out the numbers on an entire system to be able to determine exactly what's going on with that system. So let's jump right into what's going on with this particular system. So on this one here, this is a normal operating system. We're in cool mode. We've got a 75-degree indoor temperature. We've got 55-degree leaving temperature. That's a 20-degree temperature drop across the coil. Outside we've got 85-degree entering condensing temperature. We've got a 125-pound suction pressure and a 325-pound head pressure, and 92-degree liquid line temperature and a 53-degree suction line temperature. So when we throw it into the formulas, if you look up here where the superheat is, 53 minus 43 gives me 10 degrees of superheat. And then going to our subcooling side of things, we've got a 102-degree condensing temperature and a 92-degree liquid line temperature giving me 10 degrees of subcool. So that's a 20-degree drop across the coil. That's 10 degrees of superheat, 10 degrees of subcooling. You just can't ask for a system to be functioning any better than that. So where did I get these numbers though, the 102 and the 43? Well, that's right off your gauges. So if you just use your temperature conversion chart on your gauge, or use a pressure temperature chart, and you can easily get those numbers. So now keep in mind that 43 degrees and that 102 degree condensing temperature is very important. We don't really care about the pressure so much. What we really care about is temperature. The gauge pressure really just is to get you the temperature of saturation. Remember, in the condenser you're changing from a hot gas to a liquid. In the evaporator you're changing from a liquid back into a vapor. That change of state is what we're after, and we need to know what temperature that's happening. Once we know that, by getting our gauge readings, then we can use the formulas of superheat and subcooling to be able to determine what's going on with that system. So as you can see, this system's working properly. Keep in mind, TXVs, or the TXVs that NORtech uses, are set to 10 degrees of superheat. So this unit is working absolutely perfectly fine. So let's move on to the next one that I got here. So low airflow. What is low airflow going to do to the system? Well, first of all, one big thing you see right off the bat is the 105-pound suction pressure. The suction pressure dropped dramatically. We got a 34-degree evaporator temperature, 75 degrees indoor entering temperature, and 47-degree supply air temperatures. That's a 28-degree drop. That's a huge temperature drop, and that's one of the key factors with low airflow. That's one of the things you'd be looking for, is a huge temperature drop across the coil, because the coil is running entirely too cold. And you can see that in the illustration here. Look how dark blue I got this, and that suction line coming all the way back to that compressor is just ice cold. So what is that also telling you? Well, when you look at your superheat up here, 36-degree suction line temperature minus your 34-degree evaporator temperature, you only got 2 degrees of superheat. So we're on the verge of flooding that compressor back. On this particular situation, your subcooling may or may not change a whole lot. So one thing I want to point out is we got to have more than just one reading to be able to determine what's going on with the system. So we got a lot of things that are telling us that this is low airflow. The 2 degrees of superheat's one, and the 28-degree temperature drop across the coil, that's another one. So let's move on to another one here. Got an undercharge. So what's happening here? Well, again, our suction pressure is low, but look at our evaporator now. It's warm coming back. That suction line's warm coming back, and we can also see that by the superheat. You can't see it by just looking at it. You got to be able to take some temperature readings. Well, our 34-degree evaporator temperature is the same as it was with low airflow, but we got a 60-degree suction line temperature minus the 34-degree evaporator temperature, giving me 26 degrees of superheat. That's awful high. The other thing, the key factor that's going to tell you that you're low on charge, is the fact that you only got 2 degrees of subcooling. So we don't have much liquid here, even though I'm showing it red in the picture. But 2 degrees of subcooling is not near enough liquid for that TXV to have enough refrigerant to feed that evaporator coil. So this is pretty evident that this thing is undercharged. So moving on to the next one here, restriction. Restrictions look very similar to having a undercharged system, but there are some key factors that you got to look at. And one of the biggest things you're going to see when you're looking at a restriction versus a undercharge is that 17 degrees of subcooling. So now that what that's telling me is I've got a whole bunch of liquid stacked all the way back into this condenser, and it's really not doing much because it can't get in through that TXV into that evaporator. We're still starving the evaporator all the way back, just like we were with the undercharge. We still got too high a superheat. Remember, the TXVs are set for 10 degrees of superheat. I got 20 degrees of superheat. I still, the suction pressure may, the temperature, and part of what I did here was to show you that if I walked up on this system, 125-pound suction pressure at a 43-degree coil, I'm thinking, man, ain't nothing wrong with this unit. That suction pressure looks great. Well, as you can see, there is something wrong with that unit. We got 20 degrees of superheat, and we got a 17-degree subcooling. And then the other dead giveaway is we're still only getting a 10-degree drop across that coil, just like we were undercharged. More than one reading is going to give you more clues to what's really going on with that system. Hope you found this tech tip useful. Keep tuning in to edgetechhvac.com for more useful tips.